In this video, we're exposing the 10 deadliest dozer features ever built. The features that safety experts, accident investigators, and veteran operators still talk about in hushed tones. This isn't about simple discomfort or inconvenience. We're talking about fundamental flaws in engineering and safety. Flaws that turn these workhorses into death traps. Lethal designs that could kill an operator in the blink of an eye. And you will definitely want to stick around for our number one pick. It was a fundamental part of the dozer's design, a feature that defined its very shape and function. It was accepted as normal for decades, but in reality, it created the perfect conditions for the single most fatal type of dozer accident, becoming the deadliest cautionary tale in heavy equipment history. This isn't just a list, it's a tribute to the operators who face these dangers every day, and a powerful look at the brutal lessons that shaped the safe machines we rely on today. Let's get started. At number 10, we begin with the very foundation of the machine, the exposed and unguarded track system. The crawler track is what gives the dozer its incredible earth-gripping traction, but on early models, this undercarriage was a meat grinder waiting for a mistake. The massive tooth drive sprocket, the heavy steel rollers, and the continuous grinding chain were all largely exposed to the open air. The work environment was a chaotic mess of mud, branches, and debris that constantly needed clearing. If an operator or a ground worker slipped while performing this routine maintenance, a glove, a tool, or a limb could be caught in one of the many relentless pinch points. Once snagged, the machine's immense torque would drag them under with the full, unstoppable force of 20 tons of steel. The tracks, designed to distribute the dozer's immense weight, became a lethal weapon upon the slightest human contact. Coming in at number 9 is the mechanism that made every movement a physical struggle, the direct drive hand clutch. Long before the smooth application of power we see today, early dozers used a direct drive transmission. To move, an operator had to physically wrestle a massive, spring-loaded hand clutch lever. Unlike a modern torque converter, which provides a fluid, forgiving cushion between the engine and the tracks, this system was all or nothing. If the clutch was dropped too fast, or if the load was simply too great, the engine would violently stall or buck. The entire machine would jolt with a bone-jarring shudder, throwing the operator forward against the steel dashboard or even ejecting him completely from the open seat. This continuous, jarring punishment wasn't just uncomfortable, it caused long-term spinal and muscular trauma. A career behind these levers was a career of punishment, slowly but surely crippling the men who operated them. At number 8, we find a danger born not of malice, but of ignorance. The crippling blind spots. Before the advent of sophisticated mirror arrays and backup cameras, dozer design prioritized easy engine access over operator visibility. The high-mounted radiator, the bulky fuel tank, and the tall exhaust stack created vast, invisible zones around the machine. From his perch, an operator was piloting a steel iceberg, with no idea what was happening directly behind or to the sides of his machine. Tragically, struck-by and run-over accidents involving ground workers were shockingly common. Industry safety reports confirm that runovers and backovers have historically been a leading cause of fatalities in construction zones, often because the operator simply could not see the person in the path of destruction. The only defense was another human, a dedicated spotter, whose shouted warnings were often lost in the deafening roar of the worksite. Number 7 on our list is a terrifying combination of heat and fluid, the exposed engine and ignition fire hazard. The earliest bulldozers were not clean, sealed machines. They were often converted agricultural tractors with their mechanical guts exposed to the world. In this greasy, high-vibration environment, fuel lines, hydraulic hoses, and oil gaskets would inevitably leak. These highly flammable fluids would drip directly onto red-hot exhaust manifolds and engine blocks. A single spark from the steel tracks striking a rock, or a minor electrical short in the primitive wiring, could instantly ignite the atomized mist of oil and fuel. With no fire suppression systems, and the fuel tank often mounted just inches behind the operator's back, a simple mechanical failure could transform the dozer into a raging inferno in seconds, giving the trapped operator no chance of escape. Our number 6 danger takes us back to the era of pure muscle, the hand crank starter. Even after the main diesel engine became standard, starting it was a multi-stage process. Many dozers used a smaller, separate gasoline engine, called a pony motor, to turn over the massive diesel. And often this pony motor itself required a hand crank to start. The operator would stand in front of the massive machine and insert a heavy steel crank, using his entire body weight to turn the engine. If the engine unexpectedly kicked back against its compression stroke, the crank handle would be ripped from his hands, spinning backward with bone-shattering velocity. This mechanism was a brutal instrument of trauma, famously causing compound fractures to the arm and wrist. These injuries were so frequent that operators developed a special technique of never wrapping their thumb around the handle, so that a kickback would merely tear the crank from their fingers instead of snapping their bones. Halfway through our list, at number 5, is a flaw that allowed the machine to turn on its master: the total lack of operator presence interlocks. One of the deadliest design oversights was the complete absence of any mechanism to disable the controls when the operator was not in the seat. An operator might step off the machine for a seemingly harmless reason: to adjust the blade, to clear a rock, or to speak with a foreman. But if the parking brake was weak, or if the machine was left in gear on even a slight incline, the constant vibration of the running engine could be enough to make it slowly, silently begin to roll. Countless operators were killed in a moment of panic, trying to leap back onto their runaway machine only to slip and be pulled under the very tracks they commanded just moments before. At number 4, we have a failure of control at the worst possible moment: the unreliable steering clutch and brake system. A bulldozer doesn't have a steering wheel. It steers by stopping or slowing one track at a time, using a dedicated clutch and brake assembly for each side. On early models, these dry clutch systems were a complex web of plates and bands that were notoriously prone to heat fade, slippage, and inconsistent engagement, especially under a heavy load. Imagine pushing tons of rock and soil down a steep grade. The operator pulls a lever to make a crucial turn away from the edge, and nothing happens. The brake has faded from the heat. The machine, now just a runaway sled of steel, continues its path straight toward disaster. This terrifying loss of control, born from a system unequal to the forces it was meant to command, sent countless machines and their operators plunging over embankments. Our podium finish for danger begins with the bronze medal. At number 3, the cable control unit. Before hydraulics became king, the massive steel blade of a dozer was lifted and tilted by a system of drums and steel cables. This unit, mounted behind the operator, was under immense tension. It was a system with 2 equally lethal flaws. First, the cable itself, constantly flexing, fraying, and rubbing. It was only a matter of time before it snapped. When it did, the cable would whip back toward the cab with the speed of a projectile, capable of decapitating an operator. This earned the entire system the infamous and well-deserved nickname, the Widowmaker. Second, the internal clutches of the unit were prone to failure. If they let go, the multi-ton blade would crash to the ground instantly, without warning, crushing anything or anyone beneath it. The silver medal, at number 2, goes to the most glaring and fatal omission in the history of heavy equipment: the open operator cab and the complete absence of a rollover protective structure, or ROPS. For the first 50 years of their existence, dozer operators sat on a simple metal seat, completely exposed, with nothing more than a thin canopy for shade. Rollovers were, and still are, a leading cause of death for dozer operators. When working on steep slopes, unstable stockpiles, or during the treacherous process of loading onto a trailer, a dozer tipping over was a death sentence. There was no reinforced cage to protect the operator. He was instantly crushed by the machine's full weight or violently thrown from the seat and run over. While the technology for protective structures was developed as early as the 1950s, it wasn't federally mandated on new tractors in the United States until 1976, a tragic 20-year delay that cost an untold number of lives. And finally, the number 1 deadliest feature ever built into a bulldozer. It's not a single part, but a fundamental flaw in its very design that made all the other dangers so much worse: the high center of gravity combined with a rigid, unsprung chassis. Early bulldozers were fundamentally unstable. Their design placed a massive, heavy diesel engine and high-mounted accessories, like the cable control unit, onto a rigid frame with fixed tracks. They lacked the modern oscillating undercarriages that allow the tracks to move independently and conform to the ground. This created a dangerously high center of gravity with a narrow, unforgiving footprint. When working on even a moderate side slope, the dozer had almost zero margin for error. A single large rock under the uphill track, a soft spot in the ground, or a sudden lurch from a bucking clutch could instantly push the machine's center of gravity past the tipping point. This initiated a catastrophic, unrecoverable roll. This fundamental instability is the root cause that made the open cab at number 2 so consistently lethal. It was a machine designed to move the earth, but it was always one wrong move away from being tragically overturned by it. Today, these deadliest features are relics of a bygone era. They have been replaced by reinforced cabs, sealed hydraulics, seatbelt interlocks, and advanced visibility systems. We remember these flaws not to judge the past, but to honor the operators who paid the ultimate price for progress. Their sacrifice is etched into the history of every road we drive and every skyscraper we build. They are the forgotten giants who tamed the Iron Titans and whose hard-learned lessons made these incredible machines safe for the men and women who continue to move mountains today.